Mr. Davis did a great job leading us into sensation and perception. I want to talk a little bit about a few of the things that he said. I loved it when he started with a freak out, where he's thinking about how we only see a little bit of what's out there. Well, not only do our brains only pick up a little bit of what our eyes can see, we only see a little bit of the electromagnetic spectrum. When we start looking at that, there is no difference between visible light and Wi-Fi signals. There's no particular reason we shouldn't be able to see Wi-Fi signals. They're just like visible light, only at a different frequency. That's weird. Also, Mr. Davis was talking about how we don't see things, we don't fully see things. Think of your brain. Your brain is in a dark, locked room. So your brain doesn't see any light. What happens is light enters your eye, it creates a neural signal, goes back to your occipital lobe, and then it turns it into what we think we see as light. But your brain is completely dark. Your brain never sees any light. Your brain interprets information as light. Freaky stuff. When he was talking about bottom up, I love his examples of bottom up. One thing I was thinking about bottom up, I play guitar. And if I learned a new instrument, I could learn a bottom up type instrument or a top down type instrument. Now remember, top down, we're making inferences. So if I learn to play the bass guitar, that would be top down because I'm making a lot of guesses. I don't have to pay attention to everything. The fretboard looks almost exactly the same on a bass guitar as it does on a regular guitar. But think of an instrument that would have to be a lot of bottom-up processing. Like an instrument that would need a lot of bottom-up processing is a saxophone, because I don't know where any of the notes are. That would require so much more attention because I'm having to make sense of it that way. So top down is, and think about this, answer this question in your mind. Where do we spend most of our day, like today, now, in processing? Do we spend most of our day bottom up or top down? We spend most of our day in top down. We're making guesses about the world. We are in routines. We do things all the time. We're not having to make sense of the world. That's why school has been so hard to start this year. So much of this stuff is so brand new. It is bottom up processing. It takes effort. Top down processing takes no effort. It's a shortcut. We're just making a guess about things with top down. With bottom up, that is why we have been so fatigued to start the year. I hope we're getting used to it and things are becoming more top down as we move along. And then the last thing I want to talk about that Mr. Davis was talking about, transduce. Mr. Davis missed an opportunity to talk about the etymology. Duck, deuce in that means to lead, trans means across. So when information is transduced in your brain, it goes across from out there to in here. That is transduction. It is being turned into a neural impulse. So that is transduction. So sensation comes in and it is transduced into that electrical burst. Okay. So now I want to talk a little bit about thresholds. When we talk about thresholds, it's what's the difference between what we can and can't see? What's the difference between what we can and can't perceive? So what is the minimum amount of stimulus necessary for us to be able to pick something up? And this is interesting because you're going to, I think, be surprised at how fine-tuned your senses are, but you just don't pay attention to it all that much. So vision. If the world were perfect, we should be able to see one candle 30 miles away. That's how much tiny little light we should be able to perceive. So our sense of vision is very precise. How about sound? We should be able to, if I had a ticking watch, I should be able to hear it 20 feet away. And I do that in class where I actually have a ticking clock and I pull it away and people realize when you pay attention, you can hear. It's amazing how fine-tuned your senses are. We can taste 1 teaspoon of sugar in 2 gallons of water. Think of a milk jug. Think of a milk jug and think of a tiny little teaspoon. You should be able to put a half a teaspoon of sugar in there and be able to taste it. So our taste is pretty precise. Smell. If we went into a 3-bedroom apartment, we should be able to do 1 drop of perfume and it diffuses, and we should be able to smell it. It's crazy stuff. And then last, I love this. This is like a haiku. The wing of a bee falling on your cheek from a distance of 1 centimeter. If you really think, especially on your face, and I chose your face, if you think back to the homunculus, how many nerve endings there are there, how sensitive your face is to touch. So when you look at these absolute thresholds, and by the way, an absolute threshold is the point at which at least half of the people can sense it. So in other words, if the candle were 31 miles away, fewer than half of the people could sense the candle. If the candle were 29 miles away, more than half of the people would notice the candle. So that's an absolute threshold. At least 50% of the people can sense this. So absolute thresholds really point out that we're fine-tuned. It's pretty cool. But then we're going to talk about difference thresholds, which are kind of interesting. But we'll get to that in a minute. So I just want to, because this is a religion class, no, it's not, but that's fine. I just want to go through this and point something out to you. So the Lord is my shepherd, I shall not want. He maketh me to lie down in green pastures. He leadeth me beside the still waters. He restoreth my soul. He leadeth me in the paths of righteousness for his name's sake. Yea, though I walk through the valley of the shadow of death, I will fear no evil, for thou art with me. Thy rod and thy staff, they comfort me. Thou preparest a table for me in the presence of mine enemies. Thou anointest my head with oil, my cup runneth over. Surely goodness and mercy shall follow me all the days of my life, and I will dwell in the house of the Lord forever. And I'm wondering if you noticed anything. And we'll talk about this after the video, but look at how much larger the font got as we moved on. If you didn't notice the change in the size of the font as it moved forward, you didn't notice the difference. If you did, it was a just noticeable difference. See that at the top of the screen right there? It was the just noticeable difference. So hopefully many of you didn't notice the change because I kept that underneath the just noticeable difference. So that's how we're going to end this video today, talking about the two laws that go with the just noticeable difference. They call this the difference threshold. So if you did notice the change, it was above the difference threshold. If you didn't notice the change, it was below the difference threshold. So we're going to talk about turning up a stereo. Do you notice the difference when you turn up or turn down a stereo? We're going to talk about a couple of different ways to talk about how do we notice a difference? How do we notice when a light gets brighter or darker? There are certain laws, two laws that go along with this, that we can say explain when we do or do not notice a difference. So we'll look at the first one. It is called Weber's law. The just noticeable difference differs by a constant minimum percentage. And it's different for everything, but it's different for vision, it's different for hearing. But let's just talk about weight, because weight makes the most sense. If we have a 100-pound bag of potatoes, you will notice the difference between a 100-pound bag of potatoes and a 98-pound bag of potatoes. That's pretty cool. 2-pound difference, 2%, you would notice the difference. Now, if it were a 10-pound bag of potatoes, 2 pounds is way too much. You would only notice a slight change. You couldn't even take a potato probably out of a 10-pound bag of potatoes and we would notice the difference. So basically what that says is there's a constant minimum percentage. And I'll give you another example, and some of you are probably better people than I am, but I used to steal from my dad's change jar all the time. He had a huge change jar. But I, in my mind, had already kind of figured out Weber's law without knowing it. If there was a lot of change in the jar, oh, I could take a whole handful, maybe two. If there were only a little bit of, where there was only a little bit of change in the jar, I could only take a little bit. It was a constant percentage. Now, when it was, when there's a lot more change in the jar, I could get more money. When there's a lot less change in the jar, I could get less money, but it was a constant percentage. So it might have been more in the big jar in absolute terms, but it was the same in percentage terms. And again, I'm not advocating theft. I'm just saying that, you know, I'm not proud of myself for what I did when I was a kid. Okay, now Fechner's law is saying the same thing in the opposite way. Here's Fechner's law. Now you're going to look at this and go, wow, increases in strength of a stimulus produce smaller increases in perceived magnitude. What the heck does that mean? This is all that means. The two examples are great. If you keep turning up the stereo, if you turned it up 5 decibels from, say, 50 to 55 decibels, you would notice. If we turned it up from 95 to 100 decibels, you might not notice. As the original stimulus gets larger, it goes from 50 to 95, the perception goes down. So the original stimulus gets bigger, the perception of the change, the just noticeable difference, goes down. Here's another way of looking at it. I love this example. I can't remember where I got it, but let's say you have a cup of coffee, a bitter cup of Starbucks coffee, and you take a sip, you go, that's bitter, and you put in 1 teaspoon of sugar. Would you notice that? Heck yeah, you would. Now, let's say you took a sip with the 1 teaspoon and then you put another teaspoon in. Now it's twice as sweet. Would you notice the difference between 1 and 2? Probably. You'd say, ooh, that's sweeter. Now let's just keep doing that. Let's say it has 8 teaspoons of sugar in there, and I added a ninth. Do you think if I put down a cup of coffee with 8 teaspoons of sugar and a cup of coffee with 9 teaspoons of sugar that you would notice the difference? Probably not. That is Fechner's law. As the teaspoons of sugar goes up, as the strength of the original stimulus gets larger, the just noticeable difference, our increases in the perceived magnitude go down. So we don't notice that stuff. And that is why when you're in the car with your folks and you want to crank the tunes, you can turn it up a little bit at a time and they won't notice because it's already loud. If it were quiet, they'd notice. If it's loud, you can just keep turning it up little by little and they won't notice the difference. All right, I'll let Mr. Davis take it from here.